or it is 4. So this is 3 row is equal to 4a into cos of 1.3 into psi minus pi by 2. Try to understand. Is 3 row equal to, now s equal to this value 4a. Okay, so squaring and adding them. This is question number, let me write. This is the second equation we took, and this is that was third. This is fourth one. Fourth one is this. Let me write now clearly. So 3 row. Why 3 row? Because this 3 into row, and this 2 to the 4. So 4a cos 1.3 psi minus pi by 2 is equal to 3 row. 3 into row. Okay, so now these two equations we have obtained. What are those two equations? Let me write here. Okay, sorry. This is, okay, I've written down here. So we have obtained 3 row is equal to this 4a into cos of 1.3 into psi minus pi by 2. This is the angle. And second is s equal to this. And s equal to 4a into sine 1.3 psi minus pi by 2 from this equation. Because this theta we have replaced by psi minus pi by 2. 1.3 psi minus pi by 2, because half theta is psi minus 1.3 psi minus pi by 2. These two equations are there. This was, let me take second equation. This we obtained third equation. Or this was fourth one, no problem. So adding these and squaring and adding second and fourth, these two equations, what we obtain. So we obtain here finally this square is a 9 row square plus s square is equal to, here it is 4a square is 16a square. Let me take common out of these two equations. Now here it is cos square theta something, sin square theta. So first let me take sin square 1.3 angle of same psi minus pi by 2 plus it is cos square 1.3 into psi minus pi by 2. This is 1 here. So this is 16a square into 1. Try to understand. This is 16a square, therefore s square plus 9 into rho square is equal to 16a square. Is it the same value? Fifth question. Now intrinsic equation, prove that s square plus 9 rho square equal to 16a square. Okay. The same value has been proved. S square plus 9 rho square, where rho is the radius of curvature. Okay, that is ds upon d psi. Here rho is ds upon d psi. This is known as radius of curvature. This we have proved here. Same squaring these two and adding, but 16 sin square theta plus cos square theta is 1. Angle is same. That is sin square theta plus cos square theta is 1. So this 1 into 16a square, that is 16a square. Hence proved. So this is the result here. This we have to prove. Prove that s square plus 9 rho square equal to 16a square, where the rho is the radius of curvature. Done. Hence question number 5 we have completed. Now let me take 6th question. What is question number 6 says? Let me check it. Okay, now question number 6 is of what kind? This is question number 6 here. It says, this is 7th. Find the intrinsic equation of r is equal to a into 1 minus cos theta. Okay, this is here, nothing is given. Just we have to find out intrinsic equation. Okay, so that we will try to just from the vertex to the initial point. So what is this equation here? The curve is, again this is cardioid. This is also the cardioid. What is this cardioid? R is equal to a into 1 minus cos theta. This is first equation. R is given to us like this. Okay, this is the equation here. Now what is this cardioid? Let me first form this. Okay, so this is the cardioid here. Or let me just find out this cardioid as okay, so here it is. Okay, now let me just write it in the proper manner. Now here if I put 0, this is 1 minus 1 0. At 0 it is 0, r equal to 0. Okay, theta. And then at pi, if I put pi here, it is minus 1. 1 minus 1 is 1 plus 1, that means 2. That means this now at theta equal to 0, it is 0 here. So at theta equal to 0, we substitute here. It starts from angle theta here. Okay, so that is the point. If I just draw that figure here, now let me take this figure in the way. Okay, so we can just draw this figure as I just draw it like this. Okay, now I'm sorry, this figure I have to take like this. And this is also like this. This is a curve here. Now if I draw okay a tangent here at this point, so this is psi angle here, okay, and this is the vertex at this point. Now here the angle is, this is phi equal to what I have just calculated, and this is theta angle. Okay, or we can take this angle here, doesn't matter. Let me take this vertex up like this, like this, like this. Okay, so from this is the vertex here, we draw a curve back. This is S, the length of the arc, and this is phi angle. Okay, and this is the curve here, the length of this is S. This is the length here, S, this is O. Let me take origin or a point. Okay, at this point theta is 0. At this point theta is 0 first beginning, and here it is theta equal to pi, which is twice a again from this distance to this one. At pi it comes out to be 2a, it's twice a. Here it is twice a and 0. Here it is 0 and 0. No problem. This is the cardioid. Now at this point theta angle, and this is phi angle, this is psi angle. This is what we have to find out. This is S length. Okay, this is the cardioid. Now let me take everything. Solution here. So if I just find the solution of this, first we have to differentiate it. Differentiating first with respect to theta, we get this is dr d theta equal to, let me change this. So dr d theta is okay. Dr d theta from this equation is a into, now minus cos theta is, cos theta differentiated as minus sin theta, and minus plus, it will be a sin theta only, positive. Therefore ds upon d theta, which is equal to square root, let me take r square plus dr upon d theta whole square. Okay, therefore dr upon d theta whole square is square root of this value. R is that value, that means a square into 1 minus cos theta whole square, plus this is a square into sin square theta. And a, if I take out of the square root, then this is 1 plus cos square theta. If I open 1 minus cos theta whole square minus 2 cos theta, plus this is sin square theta. I have taken a comma out of the square root, I mean. This will give us a into under root. This is cos square theta to sin square theta is 1, or 1 plus, let me take sin square theta plus cos square theta minus 2 cos theta under the square root. It is nothing but a 1 plus 1 minus 2 cos theta it is giving us a under root 2 minus 2 cos theta. Try to understand. Okay, now let me further solve it here. What it gives us? It will give us, let me take a out of the square root, and that was under the square. If I take 2 common, so 1 minus cos theta. It will give us a into square root 2 into 2 sine square half theta. Why? Because 1 minus cos theta equal to 2 sine square theta by 2. As we know that since cos 2 theta is equal to 1 minus 2 sine square theta from trigonometric identity. Therefore 2 sine square theta, if I take to this side, will give us 2 sine square theta equal to 1 minus cos 2 theta. But this angle is single. Here it was double, so here it was single angle. If it is single, then it will become half. It is 2 sine square theta by 2. Okay, so it will give us twice a into sine half theta only, because sine square was there. Sine under the square root, sine square and the square root cancel out. So this is sine theta by 2 only. Okay, so this is the value of ds upon d theta. Now let me take what is the value of this is ds upon d theta, and dr upon d theta was, for dr upon d theta, it was from this dr upon d theta was a sin theta. Here it was dr d theta, that was a into sin theta only from this equation. This is a sin theta. Okay, this is there. So this equation ds upon d theta, and this is ds upon d theta here. Okay, no problem. Now we know that what is the value of tan phi. Now since tan phi is equal to r into d theta upon dr, that means r upon dr upon d theta. That means r upon r is this value. That means a into 1 minus cos theta divided by dr upon d theta, which is a sin theta. A cancelled out. It will give us 2 into sine square half theta in the numerator, because 1 minus cos theta, 1 minus cos theta is 2 sine square theta, sine square 1.2 theta divided by sine theta. Sine theta is 2 sine half theta into cos half theta. Why? Because sine 2 theta angle is, since sine 2 theta is equal to 2 sine theta into cos theta. This we know about. So we have substituted this result, but here it was sine theta only. This is sine theta only. Sine theta is 2 sine theta by 2 into cos theta by 2 from this formula, trigonometric identity. Here 2 cancel out, 1 sine cancel out. This sine half theta upon cos half theta. That means tan phi is equal to, so here we obtain, okay, so ds upon d theta was this. Let me write here. So therefore tan phi we obtain here, tan phi is equal to sine half theta upon cos half theta. That means tan sine upon cos is tan half theta. Therefore phi is equal to 1.2 theta. Here phi is equal to 1.2 theta. Okay, but psi equal to theta plus phi. It is nothing but theta plus phi is half theta. It is 3 by 2 theta. Therefore theta is equal to, or 1.2 theta if I find out, 1.2 theta equal to psi by 3, or 1.3 psi. That's the point here. Okay, now let me find out what is the relationship between this angle. So here s was equal to, what was s here? So ds upon d theta is twice a sine 1.2 theta. Okay, up to this point only we have calculated. Now let me find what is the relationship. So psi is this. Let me write here the relationships, so they will be used. So here psi angle is 3 by 2 theta. okay, or theta is equal to here, or 1.2 theta is equal to 1.3 psi. This is one relationship we have obtained, and ds d theta is this value twice a sine half theta. Okay, so now let me take what is the next thing. Next thing is the length of this arc s equal to, because relationship we will find out then between psi angle and s. So therefore, length of the arc from that vertex to that point, length of the arc of the cardioid, s is equal to limit. Now theta initially is 0 to theta, let me take 0 to theta only. 0 to theta we have taken general point theta, and this is ds upon d theta into d theta. Now ds upon d theta is this value. We substitute that value, 0 to theta into this is nothing but twice a sine half theta into d theta. So what we obtain? So here we obtain, let me take this value. Okay, so differentiation of this by integration 0 to theta here, angles ds upon d theta is this is twice a into sine half theta d theta. So integration of this will give us okay, integration of this will give us twice here. Let me take out of sine of integration. Now sine of integration of sine is minus cos half theta upon half 0 to theta. It will give us twice here, that means 4a negative sine into cos of half theta. 4a I have taken here, 0 to theta here. First is it will be cos half theta minus 1 here, because cos 0 will be 1. That will give us, let me write here, it is giving us 4a, s equal to 4a negative sign. It is negative sign here. First is cos of 1.2 theta only, minus 0 is cos 0 is 1. It will be negative sign to take negative sign to inside. It will give us 1 4a into 1 minus cos 1.2 theta. Now if I replace theta by psi angle, so half theta, this angle is 1.3 psi. Okay, so that we can substitute here. Therefore s is equal to, therefore s intrinsic equation, let me write, therefore intrinsic equation which is the relationship between psi angle, this psi angle, psi is 3/2 theta, or 1.2 theta is equal to 1.3 psi. We have s equal to, therefore 4a into 1 minus cos half theta is 1.3 psi angle. This is intrinsic equation. S equal to, s is length of the arc, and psi angle is the angle made by a tangent at P angle with the fixed line. This is psi that we just calculated there. So psi angle is this. This is the intrinsic equation, because we have to calculate only, find the intrinsic equation of r equal to a into 1 minus cos theta. That was the point. Okay, so this is the answer here. Because answer we have to find out intrinsic equation only. So question number 6 we have completed. Now let me take question number 7. Seventh question. What does it say? Now here question 7 is, okay, it says question 7 is this. Find the intrinsic equation of the spiral r equal to a theta. Okay, and where arc being measured from the pole means 0. Okay, so that we will take 0 to theta and 0 to r, because this is spiral here, equation of the spiral with respect to r. That means d theta upon dr we have to find out, not dr upon d theta, but d theta upon dr. Okay, let me take that. So this is question number 7 here. Here we are given r is equal to a theta. Okay, so first let me find dr upon d theta, then d. Okay, so this is equation number 1 here, solution. Okay, it says spiral. So r here, r equal to 0 to r. These are the limits for r here. With respect to r, we will calculate ds upon dr. We have to find out. But first, let me find what is the ds upon here, dr upon d theta. Okay, we are differentiating it with respect to theta. First, it is dr upon d theta. Therefore, b. Okay, here we get differentiating with respect to theta. We get differentiating it with respect to theta. We get dr upon d theta is equal to a only. Try to understand. Or d theta upon dr is equal to 1 upon a. D theta upon dr is equal to 1 upon a only. Okay. Yes, that is the value of d theta upon dr. Now, therefore, ds upon dr, we know that, what is that? Square root of this is 1 plus r into d theta upon dr. This we have to understand, whole square. I'm sorry, this is 1 plus r square into d theta upon dr whole square. That means this is nothing but 1 plus r square is, okay, a square theta, or let me take r square here, no problem. It is r only. D theta upon dr is 1 upon a. So this is r square upon a square. Try to understand. That will give us a r square plus a square divided by a square. That means 1 upon a into under root. This is r square plus a square. Okay, this is the value of ds upon dr. ds upon dr. But we have to find out finally relationship between. So d theta upon dr was in terms of theta. Okay, that we will calculate finally. But here ds upon dr is this value. Now s we have to find out. Now let me take. Or finally we will replace everything in terms of theta. Let me first find out in terms of r, then we'll calculate in terms of theta. That doesn't matter. Okay, ds upon dr is this value. So now let me take ds upon dr. So therefore finally s is equal to, therefore s is equal to sine of integration r is equal to 0 to r. Let me take, and this is ds upon dr into dr. This is spiral here. Okay, so spiral means radius vector we have to take, because it says from the pole, at pole r to 0. Okay, so r0 initially from to r. So this is 0 to r. So ds upon dr is this value. This is 1 upon a. Let me take outside under root. This is a square plus r square into dr. What is integration of this? Now we know that what is integration. Okay. Now integration of this will give us. This is 1 upon a. Okay. Here in 0 to r limits, no problem. Now here this is 1 upon 2r under root a square plus r square, no problem, plus 1 upon 2 a square into log of, this is r plus under root r square plus a square. This is limits 0 to r. So what is the value of this family? This is 1 upon a. If I take 1.2 out, this is 1.2a. Within bracket at r it is r under root a square plus r square. Okay, plus this is also 1.2 a square, and it will be same value log. First is log r plus log of r plus under root r square plus a square. Then at 0, first term is 0, 0 into something 0. This is here log of a. So log of a with negative sign. So if I take minus log a, no problem. It is the log this upon this, log m minus log n means log m upon n. So that means, let me write it here. So it is giving us 1.2a into r under root r square plus a square plus 1.2 I have taken outside, but this 1.2 will not come there. Only a square. This is a square log of r plus under root r square plus a square divided by a. Try to understand. Why? Because that minus log a, log m minus log n is log m upon n. This is the value. Now let me take what is theta value. So phi, because psi angle relation between s is s and psi angle. What is the value of psi angle that we have to calculate? Okay, now let me take angle psi. Now we know that tan phi is equal to r into d theta upon dr. So what does it give us? R is a theta. Let me write, or this is r upon dr upon d theta. This is r upon, what is dr upon d theta? A. Or r is a theta. This is a into theta here. Okay, so this is r into a theta. A theta upon a. So a cancelled out. Theta is equal to tan phi. Tan phi is equal to theta here, or theta, sorry, phi is equal to tan inverse. Phi is equal to tan inverse theta. Tan inverse theta here. If I take this as any angle beta, is anything given? Nothing is given, but let me take this as tan inverse theta. Phi is equal to tan inverse theta. Let us take this as beta, any angle beta. So tan inverse theta is equal to beta whenever. So therefore psi is equal to, if I put psi angle, which is theta plus phi, but phi is beta, so this is theta plus beta. In place of phi we have to replace this beta, which is tan inverse theta. We just calculate that. Therefore theta is equal to, therefore this is psi minus beta. Try to understand. Now replace theta by psi minus beta wherever theta has come up. Now r is a theta. This is a theta. So everything is to be replaced first by theta. Then theta is to be replaced in psi. That is the point. First let me convert them into theta and then replace theta by psi minus beta. That is the point. Okay, so now let me take them as this value. This was the final answer, but it is in terms of s and r only. So let me convert them first into theta. This is 1 upon 2a. R is a theta. This is a into theta. Under the square root, it is r square, a square, theta square. So this is a will come out, a square will be there then, because this, and it will be then 1 plus theta square plus a square. Now this is a square here, no problem. Log of r is a theta plus again this is a. If I take common under root, it will be 1 plus theta square. Sorry, 1 plus theta square inside. A square plus a square theta square. That means theta a we have taken common. upon a here, so a cancelled out inside. This is theta plus under root 1 plus theta square. Okay, so this is a square. If I take outside, it will be a square upon 2 means a upon 2 here. This is theta under root 1 plus theta square. Okay, plus this is log only now, log of theta plus under root 1 plus theta square only. This is value of s in terms of theta, but theta is this psi minus beta. So let me put here psi minus beta, where beta is that value. Okay, so theta is psi minus beta here. We can substitute it. This is a upon 2, therefore s equal to theta is psi minus beta. What is beta here? Tan inverse theta. Okay, this is under root 1 plus psi minus beta whole square inside value plus log of this is psi minus beta. We have taken this theta plus under root 1 plus psi minus beta whole square. So this kind of equation is obtained a relation between s and psi. Okay, but beta is here, where beta is equal to tan inverse theta. Here tan inverse theta we took. Okay, because theta, this phi was tan inverse theta, or which we took as beta. So this was theta plus tan inverse beta, tan inverse theta I mean. Okay, so theta is equal to psi minus tan inverse theta. So beta we are taking, so beta is here tan inverse theta. So this is the relationship, intrinsic equation. This is the intrinsic equation of question number 6 here. Question number 6 is finally complete. Sorry, 7th. This is question number 7 here. Okay. So this is question number 7. I'm sorry, this intrinsic equation. A relation between s and psi. The angle between tangent and the fixed line. Okay, tangent at a point P here we take, and then a fixed line. That's the point. Now question number 8, if I take. Okay, now question number 8 here. This is 8th question. It says in the curve x2 by 3 plus y2 by 3 equal to a2 by 3, show that s equal to 3 upon 4a cos 2 psi, where s being measured from the vertex. Okay, from vertex it is to measure, no problem, and s equal to 3 by 2a sin square psi, where s is being